All right, here's number 4. This is just a chance to give you, it was just a problem to give you a chance to show me that you know U substitution. These all require U substitution. And then there's other types of antiderivatives you can use. Okay, so here, let's do letter A. So in letter A, I noticed that if I let U be 1 plus cosine of t, now there's more than one ways to do this, but this is the way that I would do it. Then du is negative sine t dt. Now I did notice that one of you decided to let u be cosine of t, and du is negative sine t dt. You can still make that work, okay? It's just not the way these are not ever unique. It wouldn't be the way that I would do it, but that should be possible. All right, so there is that, and then again, my domain. So the x's go from 0 to pi over 2. And so the u's, so 1 plus cosine of 0, which is 1 plus 1, so that's 2. And then 1 plus cosine of pi over 2, cosine of pi over 2 is 0, so that's 1. And so then this antiderivative, 0 to pi over 2 sine of x, 1 plus cosine x dx. This becomes, I'm going from 2 to 1. And, oh, I forgot to do something. Well, let's see what I can do. So I notice that the 1 plus cosine gets replaced with u. And then I have a sine x dx. I see the sine x dx here. For some reason, I use t. Maybe because it's 3 in the morning, and that could be a reason why. It's supposed to be an x. Okay. So now I see the sine x dx. So let me just multiply both sides by -1. So negative du is sine x dx. That's a little bit better. And so now I can replace the sine x dx with negative du. So when I go over here, I get negative du, or maybe -1 du over u. That might make it easier to see what's going on. And so then here, I'm going to take out the negative 2 to 1, 1 over u du. But then I said that that negative can always switch the integral so that it looks a little bit nicer. And here, this is the natural log of u from 1 to 2. And the natural log of 2 minus the natural log of 1, or just the natural log of 2, since the natural log of 1 is 0. One thing about this, I noticed that some of you are struggling with notation a bit, so I should have mentioned this in the other videos, but as soon as you take the antiderivative, notice that this symbol and this symbol are gone because you've taken the antiderivative. And that's when you use the new symbol, where the new symbol is this line with what you're going to plug in. So I just want to make sure you're clear that that's the correct grammar, that's the correct notation. And math is more than just trying to get the right answer. It's also about learning how to write well, and especially how to write mathematics. So this is sort of the grammar of mathematics, especially the grammar of calculus that we want you to get. All right, letter B. Here, what I notice is that if you let u equal sine x, then du is cosine x dx. And the reason this is important, of course, is here's the sine x. So there it is. So I can replace that with u. But then, and I should have used, yeah, good. And then I notice there's a cosine dx, and here's a cosine dx right there. So it's actually set up really nicely. So all that's left is the domain. So my original domain seems to be from 0 to pi. So my new domain, u, is sine of x, and then the sine of 0 is 0, and the sine of pi is 0, and that's kind of cool, because now you have this antiderivative 0 to pi cosine x e to the sine x dx, which becomes e to the u du from 0 to 0. And of course, this is just going to be 0, but let me do it anyway. This would be e to the u from 0 to 0. From 0 to 0, which would just be e to the 0 minus e to the 0, which is still 0. Or in other words, 1 minus 1. Still 0 though, regardless. So that's really all there's to this. This one is done, and hopefully it's done well, nicely for you. All right, part C. I'm going to go from -1 to 0 of x squared here it's the cube root of x cubed plus 1 dx. And actually, I'm gonna, oh, well, we'll do it there. Sorry. Like I said, it's late. I'm trying to think clearly. Here, what I notice is that if u is x cubed plus 1, then du is 3x squared dx. And the reason that's important is that, again, the x cubed plus 1, that's on the inside of some type of function. But if you notice, on the outside, I have x squared dx. And here I have x squared dx. I just have that 3. So to get rid of that 3, I divide by 3. And now I have x squared dx by itself. And so now I know I can replace x squared dx with 1/3 du. And now my domain, okay, x is going from -1 to 0. Here it's going to be x cubed plus 1. So this is going to be -1 cubed plus 1, which is -1 plus 1, which is 0. And then 0 cubed plus 1 is just 1. So then my definite integral goes from 0 to 1. That's my new domain. It's going to be the cube root of u. So here I'm replacing the x cubed plus 1 with the u. And then I'm going to go ahead and replace the x squared dx with 1/3 du. So I'm going to go ahead and write the 1/3 right here and the du over here. The 1/3, it's a constant, so we can write it outside. And so here I'm going to do a little bit of reminding you of algebra. This is just algebra. The cube root of u is u to the 1/3. Okay, so that's just algebra. That's not even calculus yet. Now I'm going to go ahead and take the antiderivative using the power rule. So that's 1/3 plus 1. 1/3 plus 1 is 4/3. So you divide by 4/3. And I'm going from 0 to 1. Dividing by 4/3 is like multiplying by 3/4. You divide by a number, you multiply by its reciprocal, and it's going to be u to the 4/3 from 0 to 1. So I get 1/4, 1 to the 4/3 minus 0 to the 4/3. And luckily I picked nice numbers because this is just 1/4, 1 minus 0, or in other words, just 1/4. So again, I hope this helps with number 4. And I'll continue with the newer ones. Since a lot of these are new and we haven't seen too many, I want to make sure you get as many examples as possible.